Okay, in this video we're going to talk about using symmetry to sketch graphs of equations and talk about our rules of symmetry and what symmetry is. Let's start with x-axis symmetry. So here in this picture you see we've got a picture of a mountain that's reflecting on the water. So you can kind of say if this were the x-axis, this is called x-axis symmetry. Notice here we've also given you a graph. Notice here's the x-axis for each point that's above the axis. There's one that matches it that is below. So we say a graph is symmetric with respect to the x-axis if the point xy on the graph, there's also a point x negative y that's on that same graph. So, if I were to pick a random point, this point 1, 3, the point 1, negative 3 would also be on the graph. Okay, let's take a look at what y-axis symmetry looks like. Notice here in this picture, I've given you a picture of some dolphins and the path that they're taking, and their path kind of looks like it's symmetrical to the y-axis. So we've got this kind of upside down parabola. Notice in my picture of my Cartesian plane, I've got a point on each side that matches up, so that would also be an example. Basically, if I take and I fold the plane right on the y-axis, the points are going to match up. Kind of like what we do, in Valentine's Day, making hearts. So we say a graph is symmetric with respect to the y-axis. There we have a point xy, and also the point negative xy is on that same graph. So, if I were to pick this point 2, 4, the point negative 2, 4 is also going to be on the graph if it's symmetrical to the y-axis. Okay, the third type of symmetry we're going to talk about is what we call origin symmetry. And what origin symmetry basically means is if I take and I fold across the x-axis, then I fold across the y-axis, those points are going to match up. So a graph is symmetric with respect to the origin if we have a point xy, which in this case we actually have AB, and then the point negative x, negative y, which in this case is negative a, negative b. And that would be symmetrical with respect to the origin. Okay, let's talk about some of our algebraic tests that we use for symmetry for all three of these situations. So the first one we talked about, x-axis symmetry. Basically, if we take and we replace y in the equation with negative y, and the equation remains the same, then we know it has x-axis symmetry. If it's symmetrical to the y-axis, and we take and we replace the x with negative x, and the equation remains the same, then we know it has symmetry with relation to the y-axis. The last one then, the origin. For the origin, if we replace the x with negative x, and we replace the y with negative y, then that will yield us or also give us the equivalent equation. Okay, so those are our tests. We're going to demonstrate that in these next two slides. So let's say we have this equation, y equals x squared minus 2, and we want to know, does it have symmetry with relation to the x, y, or the origin? So let's start with x-axis symmetry. So x-axis, remember for the x-axis, I'm going to replace the y with a negative y. So if I put in negative y into my equation, and it yields me the same equation, then I know that it has symmetry with relation to the x-axis. In this case, this equation is not the same. So this does not have x-axis symmetry. Now, let's try y-axis symmetry. Y-axis symmetry indicates that I'm going to put in a negative x wherever there is an x. So this would be y equals negative x squared minus 2. Well, if I go through that process, y equals, and again I get rid of the parentheses, it yields me the same equation. These two are the same, so yes, this would have y-axis symmetry. Let's check the last one, the origin. The origin would be, I'm going to put in a negative y for y, and I'm going to put in a negative x for x. And if that yields me the same equation, which if I simplify it, negative y equals x squared minus 2, well, those are not the same, so this would not have symmetry with relation to the origin. So in this case, just the y-axis for this example. Okay, let's do one more example for that, just to demonstrate again the situation. So let's say our new equation is y equals x to the third minus 4x. Again, let's start with the x-axis. I'm going to test x-axis symmetry. I'm going to put in a negative y. And again, this does not yield the same, so therefore no x-axis symmetry. For y-axis symmetry, I'm going to put in a negative x anywhere that there is an x. So negative x, and that's cubed, minus 4 times a negative x. So if I go through that process and simplify, I get y equals a negative x third plus 4x. Again, in this situation, not the same equation, so no symmetry with relation to y. And then the last situation, the origin, again, I'm going to put in a negative y, a negative x, again, a negative x. And if I go through that process, I get negative y equals negative x to the third plus 4x. Well, again, if I multiply through by a negative 1, y equals x to the third minus 4x. And I see that these two equations are exactly the same. So in this case, this particular equation has symmetry with relation to the origin.